Okay, so now we are on to number 5, which is just differentiating some functions. 5a says to us, let's differentiate g of x equal to 4x squared minus 3x to the 1/3 power minus x to the minus 4 power. So this is just the power rule, and also using the fact that derivatives of constant multiples, you can leave the constant alone, and that derivatives of sums and differences, you can just differentiate each term. So the power rule says bring the power down and then reduce it by 1. So the first guy, the derivative of x squared, is 2x to the first power, or just 2x. Since there's a 4 there, I multiply 4 against the derivative of x squared, and I get 8. What is going on? 8x. All right. The next guy, I bring the power down. The power is 1/3. 1/3 times -3 gives me -1. So -1 times x to the 1/3 minus 1 is -2/3. And finally, x minus x to -4. Bring down the power. -4 times -1 gives me +4. So plus 4x to the, I reduce -4 by 1 to get -5. So that's the derivative there, 8x minus x to the -2/3 plus 4x to the -5. Part B gives us the function, why is it p of x? I don't know, that's just what it is. P of x is equal to 2 times tangent of x minus 3 times cosine of x. And we take the derivative here. Again, this is just using the fact that using facts about derivatives of constant multiples and of sums or differences of functions. So I get to leave the 2 here and take the derivative of tangent. The derivative of tangent is secant squared. I still see people trying to use the power rule to take the derivative of something like 2 times tangent. I've said it a lot of times, I'll say it once more. It's just a constant multiple. You can just leave the 2 there and go home. It's fine. Okay, -3 times cosine. The derivative of cosine is negative sign. So the -3 times the minus from the cosine, the derivative of cosine rather, gives me +3 sine x. Fantastic. Let's keep going. So if that was too fast, well, go back and pause it. Okay. So 6a gives us f of x is equal to the natural log of x times the square root of x. This is something where you need the product rule because it's log of x times the square root of x. It's a product. It's a product of 2 non-constant functions, so that's what it is. Now, it's always nicer to rewrite roots as powers of x, so I'm going to rewrite the square root of x as x to the 1/2. Now let's take the derivative. Remember, the product rule says that if I've got u times v, and I take the derivative, I get u prime v plus u times v prime. So first I take the derivative of the natural log of x, which is 1 over x, and I multiply by x to the 1/2. I leave that guy alone. Then I add the natural log of x times the derivative of x to the 1/2, which is 1/2 x to the -1/2. All right, just the power rule. That's it. If you want to make it look prettier, go ahead. I'm not going to stop you, but this is good enough. Okay, B is a little bit harder because I give you g of x is equal to a product of 3 things, x times e to the x times sine of x. So let's just recall that the product rule generalizes to products of an arbitrary number of factors as follows. To take the derivative of vw, it's u prime times vw plus u times v prime w plus u v w prime. So I get to take the derivative of each factor one at a time, and I leave the other guys alone, and I add the results together. So the derivative of g over here is, first I take the derivative of x, which is 1, multiplied by e to the x and sine of x. So I just took the derivative of x there. The next time around, I leave x alone. I take the derivative of e to the x, which is itself, and I leave sine there. The last time, I leave x and e to the x, and I take the derivative of the last guy, which is sine. The last factor is sine, its derivative is cosine, and this is the expression I get. Great. E to the x sine of x plus x e to the x sine of x plus x e to the x cosine of x. You can also solve this by sort of iteratively applying the product rule if you want to sort of parse it as x times e to the x, quantity times sine of x. Then this could be your u, and this could be your v, and then when you go to take the derivative of u, you're going to have to apply the product rule just to x e to the x. Go ahead, do that, whatever. You'll get the same answer. It might look slightly different, but it's the same. Okay, yay. Oops.